Anyway,
Domenico, put yourself on mute.
Oh.
It should be fine. It looks like it's coming across just fine right now. So Domenico is going to share with us their potential collaboration with ONOS, and I'm just going to let you take it from here. Okay?
Okay, great. Thank you. So just to introduce myself briefly, I'm Domenico Siracusa, senior researcher of the Future Networks group within CREANET. The Future Network Department is engaged in research and development on wired and wireless networks. We currently have different projects on the subject of transport networks, converged networks, and 5G networks. So as of today, my idea was to present what the ACINO project, a H2020 EU project, is currently doing and plans to do in the next future, and see what are the possibilities to have collaborations and, let me say, investigate possible collaboration with ONOS as well. The presentation has been structured in a way that I start presenting you the idea of the project, the main concepts, and then I have a part related to what we could do and how we could potentially innovate what is currently available within ONOS. Feel free to interrupt me and make questions, of course. The idea behind the project started with the fact that we think that today's transport networks may be classified in three main layers. On top sits the applications, which are driving the ultimate requirements and which are driving the ultimate requirements for the network. On the middle layer stands a grooming layer. This grooming layer is basically the AP layer. What happens is that all the traffic that is sent by this application is groomed and sent together through an optical pipe that stands at the fixed transport layer. This is basically creating an effect for which all the application requirements, despite them, they more or less, because the grooming layer is basically sending all the things through the optical pipe. So what happens for both? What happens is that many low bandwidth applications send the traffic with application-specific requirements, and this is groomed into aggregate requirements for high bandwidth. Of course, this means that the specific requirements are not satisfied. So the part which is satisfied is the aggregated requirement. And we thought that there are some trends that could change this paradigm. Basically, we have seen that by the time passes by, applications, and in this moment I'm not referring to applications as applications of a controller, as maybe we are used with SDN. I'm talking about applications that are at the end of the story generating the traffic for the transport network. We are seeing that the bandwidth that these applications are requiring is always increasing and increasing, and at the same time we have that the granularity that can be served by the optical technology is always less. So basically there is a reduced gap between the bandwidth required by the applications and the offering by the optical services. So this may spurred us to think to the concept of application-centric IP optical network orchestration, which is for which the acronym is basically ACINO. And the idea is then to differentiate the service offered to each application all the way down to the optical layer, which means that we always think of this division into multiple layers, and then for the applications with medium or high bandwidth with specific requirements, we try to satisfy them not only at the AP layer, but all the way down to the application-aware transport layer. And for those for those applications that are low bandwidth, we try to groom them, but not just depending on maybe, for instance, the input port, but on the basis of their app class requirements. So at the end of the story, the concept that stands behind ACINO is let's try to see what are the requirements of each application, and let's try to organize and optimize both the IP and the optical layer in order to tailor the service we are providing to their specific needs. And so the basic part of the solution is depicted in this slide. So we basically have the different application needs, which may be, for instance, the duration, which may be the survivability. For instance, for the survivability, we may think, okay, the application doesn't want to have a downtime that is higher than a certain threshold, or it wants to have some kind of security, or a certain duration, or a certain capacity, or in terms of jitter. So all this application, all these needs are peculiar of the specific application. An application so requests for a service through intents. This is really important for us. I know it is already a feature of ONOS, but this is really important for us because we think that the application shouldn't be aware of the specific of the network. And when it comes to multi-layer networks, there are a lot of technology-specific details that we don't think applications should know. There is, of course, an intent engine that shall translate these intents into real service requirements. So starting from I want such bandwidth with such latency, and I don't want to have more than 40 milliseconds of downtime, to something that is more in terms of service. So it means that you have to establish an MPLS tunnel, and you have to establish a light path, and you want to have a specific survivability mechanism, which could be at the IP layer or at the optical layer. So once these intents are translated into requirements, we should have a resource manager that by gathering information from a multi-layer network model is able to make an appropriate allocation of resources and mechanisms. This means that the decisions are made either at one or at the other layer according to the needs of the applications. The example I was given before is okay, I don't want to have a certain downtime. If the downtime is really short, you may want to use the IP protection. If you have some time, you may want to use optical restoration, which is more effective in terms of usage of resources, but it's clearly slower. So it depends on the needs of the application. So each application may have a different need. For each of them, we may want to configure the multi-layer network accordingly. Of course, once the solution has been found, we need to go for the network configuration. So go for the abstraction layer and to the providers in order to configure the devices. There is also one thing we were thinking about is if we should give some feedback back to let me say, to the algorithm that is translating these intents to requirements, and if it is the case, to have further interaction with the application. I will go into this also later. Another thing you can find in this picture, and please consider that our ideas were not related at the beginning with what you can find you have developed within ONOS. So some terms can be used in a different way as you do. we were thinking about these primitives. The idea was that we were going to expose to the applications all the constraints and the possible intents that they can express, basically. Of course, if the application don't know what you can provide, you need to at least provide some templates in order to understand how this can be provided. About the implementation, we were thinking to develop an open source orchestrator. Why we are talking about the first of all, why are we talking about an orchestrator? This is a generic term that has been emerging recently to detail a control plane for multi-layer, multi-technology, and even multi-domain networks. The idea is that we will have these applications on top, and again, I'm not talking here about the ONOS applications, the controller applications, but the applications that are that I've been referring so far. And we also have a network manager. So this is the part of the orchestrator, which will have an engine for these intents and a multi-layer resource manager for basically what is referred in ONOS as the compilation of the intents, as far as I got. And then the abstraction and configuration. This orchestrator will work on top of IP controller, IP devices, optical controller, and optical devices. I will go a little bit into this. Basically, we believe that it is better, it will be definitely better if this orchestrator doesn't configure directly the devices, but instead it deals with the controllers. In our opinion, this makes sense, especially when referring to the optical domain, because we expect that vendors will produce their equipment and equip them with their control plane. This control plane of the optical device will take care of many operations that are not related with the management of resources on which we are interested. Basically, for instance, the tuning of the filters, or the amplifiers, the filters, and a lot of procedures related with the physical layer impairments are not really interesting for the operations that the orchestrator should do. And we don't expect that this will be exposed by the vendor of the optical devices. Finally, we will also have we are also planning to develop an online planning tool. This is the idea behind this component is that it should be a tool that allows to compute what-if scenarios, which means, for instance, the manager, the network operator basically asked to this tool, okay, what happens if I disconnect this fiber? What happens if I had a fiber, or this link goes down, and so on and so forth. And also, it should address network reoptimization. So something that is not as dynamic as the operations that are done by the multi-layer resource manager. To make it, to say it in a different way, basically the applications with their requirements should necessarily go for the intent engine, because they don't care about how the network is done and what is beyond the orchestrator, while the network manager may be interested in optimizing the network or seeing what happens in certain scenarios. That is why it goes for the online planning tool. On the manager could also request for the instantiation of new services, and he can use the intent engine as well. For the sake of the implementation, this is the rough high-level idea. We plan to demonstrate this in an emulated scenario where we shall be able to use virtual routers and virtual optical devices controlled by an optical controller. We also have some implementation of an implementation of optical controller here within Creanet, but also one of the partners, ADVA, as of course their emulated control plane. And this will be also demonstrated in a physical testbed in Telefonica premises. This brings me to this animation was to say, okay, this is the part that will be developed by ACINO. This brings me also to just briefly say who are the partners involved in this consortium and who are the partners working in this joint effort. And there is, of course, Creanet. We are the project coordinator, but we also have other two research centers, the Athens Information Technology in Greece and the ACRIO from Sweden. But on the industrial side, we have Telefonica. I already introduced them, the Spanish network operator, and they are gonna participate to the research and development efforts. But they are gonna provide us the testbed over which we will test the ACINO solution. Then we will have ADVA, a system vendor from Germany, and finally there is also an SME from Israel, Sedona System, which is working on subjects related to ACINO, basically on multi-layer orchestration. We also have today on the call Yona from Sedona.
Hello, you.
So the second part of the presentation, I hope I'm not taking too much time because I guess that the most interesting part is related with the discussion. The second part is basically what ACINO brings, what is the novelty that ACINO brings to the table, and basically related with the control and what we call the orchestration. The first thing that ACINO brings as novel to the table is the specific treatment that we want to give to applications that currently, as far as I know, is not something that is addressed in other projects related with transport networks. But with respect maybe to ONOS, what we have, what can be interesting for ONOS is that we want to do a strong characterization of an IP optical use case in a scenario where there are different equipment vendors and control planes. And I try to highlight some, I will try to highlight in the next slides some technical novelties which could be of your interest, as well as improvements to what you already have and maybe can be a little bit improved according to our use cases. At the moment, I'm referring to the packet optical use case, and my information are not really recent. They may be outdated of 10-20 days because this is the status of the latest information have about the packet optical use case developed in ONOS. And we have identified basically 4 subtopics that could be of interest: the management of intents, the online planning, the network model, and the southbound interface and the configuration. With respect to the management of intents, what we are currently thinking about is what could be really interesting possibly is the fact that we want to extend the intent framework. We could extend the intent framework in order to allow more effective bidirectional communication with the clients. As far as I got, currently the intent that I have seen, let me say the working process of the intents within the packet optical use case is basically that you ask a host-to-host connection. This is automatically translated into one request for the optical layer, which is implemented through the shortest path, basically. So the first thing we are thinking is about to allow these intents, first of all, to have new intents, basically. Let me go in this direction, which are related with our project use cases. for inter data center communication, for CDN and TV broadcasting, and 5G transport. These are our use cases. We are pretty sure that there could be more intents that can be added on top of the ones that are already available with ONOS. One of them could be, for instance, that you want to interconnect more data centers, and you want to have specific survivability among these data centers that may request the connection of multiple sites at the same time. New constraints, because these new intents may be also related to new constraints that are, for instance, about the survivability on the fact that you want to express this in a different way than in the past. And new methods to compile intents, which are basically algorithms. As far as I've seen, what is available currently, as I said before, is just going through the optical layer and the shortest path. Of course, this can be done much more efficiently when it comes to the usage of network resources, and it could be much more detailed with respect to the constraints you are considering, because actually there are no constraints considered rather than the availability of a wavelength, if I'm not wrong. Furthermore, another thing we were considering is to, on the topic of bidirectional communication with the clients, is that, okay, I give you an intent, but at the same time I ask you a service with an intent, but at the same time the orchestrator may say, look, it is not possible for me to comply with the intents you have, and then start something that could be thought as a negotiation with the application. So this is another thing that we are considering, and we may go with. The second point is about the online planning. I see this is something that could be of interest or not, and it is a novel functionality that is addressing long time scale operations, as I said before, what if scenarios or re-optimization. This could be an ONOS application in the normal term. Let me pass this. Let me pass this in this way. So it could be not in the core, but an ONOS application that could reuse the knowledge of the network model that we will expose to perform these operations. We are currently evaluating different alternatives. One is an open source software called NettoPlan, but we are also thinking about some customized solutions. The network model discussion is quite complex with respect to the previous ones. We have seen this is a table that we have prepared. It doesn't want to be a complete comparison, and there could be something on which you may not agree. It serves to convey the message that there are different models with a different structure, and we may want to take something from one or another model. So as far as we have seen by looking at the information available from the two first standardization bodies, which are basically IETF and ONF, we are seeing that the IETF model is basically a hierarchical model, which has some information related to the IP part, but a little bit less related to the optical. We have divided this into two kinds of information. One is the topology, and one is about the configuration of the network. Related to the topology, we have seen that on the IP part, of course, there is the material we are searching for. Regarding the configuration, there is no much, but we have seen that there are some data models provided by the OpenConfig, and this could be useful. This could be used for this purpose. Related to the optical part, there is the topology part is really the generic the generic topology you have for each kind of technology and network, and there are no specific optical parameters also for the configuration. The ONF model is recursive. It's a different kind of model. It's a recursive. There is for the topology, you have it, of course, but there is no much on the configuration of IP devices, while there is more on the optical side, which specifies the topology with few parameters, despite there is nothing for the feasibility evaluation, and there is something for the configuration, and specifically the transport API that is currently under discussion within ONF. We have tried to understand also how the ONOS model works. And as far as we got, I also had a discussion with Mark Delaner a few months ago, and we understood that the structure of ONOS is basically flat. However, to our understanding, in the packet circuit, in the packet optical use case, nodes are labeled, are tagged, which means that by this tag by using these tags, we can think that this flat model may be also thought as a hierarchical model, because you go from one layer, let's say, to another layer by using these tags. The difference is the point is that, of course, all the nodes are of the same type, let me say, but tagged differently. So on this case, you know very well about how it works, but what we understood is that for the topology on the IP side, we're okay. For the configuration, you're mostly using OpenFlow, and you're managing everything as a switch, and there are not the same parameters that we can configure on IP routers. On the optical side, we have seen that the topology is quite okay. There are when I say okay, I mean in line with what we will need, of course. We have seen that all the nodes you have lack an internal connectivity matrix. We were thinking about it. This could be fine if you consider that all the ROMs are connectionless, directionless, and contentionless. At least, they should be connectionless and possibly directionless. If not, it will be better to have a connectivity matrix inside the nodes. We have seen that there should be no transceiver model, and there is something about the FlexiGrid, but we are not sure if it is used or not. The configuration again is OpenFlow. There are a few parameters there. We may need to broaden the set of parameters used. What we thought about the network model, then it's okay. The ONOS model should be fine for our purposes, so it is useless and it will not make any sense to try to change the basics of the model. Rather than, it will be better to try to represent our instance with ONOS model and add parameters and characterization of the IP and optical topology and configuration that is currently missing according to our understanding.
Okay.
Related to the southbound and the configuration, this is, I think, one of the last slides. The ACINO orchestrator is supposed, as I said, to interact with the controllers. This is almost something that we all in the consortium will agree for the optical. There could be some cases in which we may need to interact with the controller, not only to ask for configuration. For instance, we may want to ask the controller, okay, look, I want to do this at the optical layer. Can you check the feasibility for me? That could be an option, for instance. And we would like to do this also with IP routers, but it may be the case in which you need to do some direct configuration. For instance, we have seen the controller of from Juniper, the North Star. You can ask for the instantiation of MPLS tunnels, and you can also pass, I guess, I think, the full hero. But for instance, you cannot say, okay, I need a port here and there, shut down the port, and so on and so forth. And related to the southbound, to the protocols, we are thinking about many solutions. For instance, to use the OpenConfig models with netconf to PCAP. I know that there should be an implementation of PCAP and netconf as well, but we haven't tried it. And for instance, we may think to implement the transport API to have a common API with the optical controllers as defined by the ONF, or some custom interfaces. Related to the timeline, I'm putting here a rough one. Basically, the idea was that by the end of July of this year, let's say July, August, we should have an early release of the Orchestrator. So improving the model to see the first providers, if the one, for instance, if the one that are provided by ONOS are enough, or we should extend them, and have some early planning tool and intent engine. By May of 2017, we should have the final implementation of the planning tool and the intent engine. And by the August of the same year, we should finalize the implementation of the Orchestrator, including the providers, the full set of providers we need. Then we will try to improve things and finalize all the work to have the final demonstrations that, as I said, will be held in Telefonica by the end of January 2018. This is basically a rough timeline for our work. And okay, so basically the point is one of the main things I was interested, we are interested by having this telco is if this is interesting for you, and if there is the room for an official collaboration with ONOS, and how and what are the perspectives for that. Finally, just to mention this, few information. Okay, this is a slide about information about the project, the website, the Twitter account, and the email. But I guess this was circulated also in the mailing list, so basically it's not really important. So that basically concludes my presentation. Sorry for taking a long time, and thank you for the attention.
Yeah, no, this is great. And to answer your last question, I definitely think that there is room for collaboration. There's number of areas which actually somewhat overlap with some of our either existing or planned efforts, but I think that only emphasizes the need for collaboration. So specifically with respect to the model and the ability to configure devices using different protocols, they have this matrix right here. Actually, the previous one that you have.
Sorry.
Yes. Yeah. So yeah, definitely we purposefully keep the model flat, the structure flat, and the idea is that you can extract subgraphs from the overall graph. It is not entirely correct that configuration is possible only through OpenFlow. As a matter of fact, we're structured to allow configurations through pretty much anything that you can throw at the devices. It's just that
this might be in the context of the existing intent framework.
It could.
The existing intent framework is
correct.
flow rule centric, which is mostly OpenFlow.
That's true.
So
Yes.
I don't know what the configuration characterization here means.
That's true. Yes. So in a context of open intents, that's I suppose that's correct. However, in the broader context of ONOS, you can certainly you should certainly be able to define abstractions for configuring aspects of network elements which are quite far away from just traditional switches. What's
Okay. We need to have a closer check, of course.
Well, no, the thing is, so, you know, we've introduced device drivers, I think, in Blackbird. And then we started to use them in Cardinal for small things, small things, select few things which are still very important, like, for example, our pipeline independence for flow objectives, and also for isolating device-specific behaviors with respect to OpenFlow. Because our general philosophy with respect to both modeling and interfacing with the environment is we definitely want to exploit and benefit from the standards, whether they're standard protocols or standard models. However, we do not want to depend on them because we understand that devices implement them to various degrees, if they implement them at all, and we simply want to make sure that ONOS can accommodate even today's devices, even if it's just in a limited fashion. And so for that reason, we create our own abstractions, our own models of behavior, and this is what the driver framework is used to deliver. And it can be used both in terms of modeling the interactions with the devices for the purpose of configuration or control, but it can also be used in a context of modeling the information learned about the devices. So it can be also used as a mechanism to extend the model while still keeping the base abstractions sort of untouched, and the core can be kept completely agnostic of what those specific models are. Because one thing we want to avoid is this sim-like explosion of classes and complexity of the model. So that's something we're trying to fiercely protect. So there's going to be work occurring to facilitate use of the drivers for both configuration and for model extensions, and we're actually starting to do some of that work with for the microwave use case, and we'll actually be using this retroactively to retrofit some of the optical models, which actually introduced some, and I've talked with Mark about this, introduced some basically steps in the wrong direction, where we're starting to explode the model based on basically domain or media specific attributes, and we want to sort of retract that and instead use this new more friendly way of extending the model. And so I think this is perfectly in line with what you're trying to accomplish, and we'll be definitely happy to work with you to make sure that we can capture the modeling specifics that you require. One thing that we currently don't have today, as you observed, is we don't really have any connectivity matrix. We sort of assume naively that once you reach the device as a vertex of the graph, you can traverse out to any edge, which is certainly not the case for many optical devices.
Exactly.
That.
You consider especially legacy devices, this is highly possible that you will not have the possibility to go from each side to the other sides. So, I mean, of course, at the first, in the first approximation, this is good if you assume that you have specific, like modern devices, CDC devices. But as you said, maybe for some cases you will need to have further information.
Yeah. So definitely, I think the possibility for collaboration here is to make sure that we work with you to, as you start to extend the model, we want to make sure that you do so in a way that's consistent with our long future directions. And so I think it will be important to work together on this, just to make sure that you don't, for example, follow the footstep of the current optical extensions, because those will actually be going away. That's one area of opportunity. I'm also really intrigued with network planning. That's an interesting concept. And in the areas of the intent work. So currently our intent framework has been undergoing only slight evolutionary changes, improvements both in robustness and in resource reservation, and small incremental changes. But we've been spending significant, we spend significant cycles to figure out how to overcome a couple of what we view as limitations of today's intent framework, specifically to allow it to scale better, to also give different regions more freedom of how it goes about implementing those or satisfying those intents. Because, for example, today you will see that there are optical intents versus packet level intents, and that exposes far too much information to the applications. Applications should be able to just specify that they want some basic primitives such as tunnels or broadcast trees or default routes and things of the sort, primitives that can be reused. And also, as you observed, currently there is limited feedback that the application get about the nature of the of how the intent is going to be satisfied. And so there is some planned work in this area. It's been getting pushed off due to higher priority items, but we do plan to spend some time on it in the follow-on 2 releases. And we refer to this work as intent domains. And it also, yeah, so this would be one additional area of potential collaboration. So it'll be, we should at least have a dialogue to see what you're looking there, and then maybe run some of our ideas by you to see, you know, to learn from that. So at least 3 different areas that I see in here is the intents, you know, evolving the intent subsystem, the model extensions, as well as the online planning. We really don't have any specific plans in that area. So, but I'm still intrigued to see, because this would really be a nice add-on to ONOS to be able to provide more foresight and making deliberate decisions about the use of network resources.
Okay. I think this is a great feedback for us. Some hiccup. Okay. No, I still have. I don't know. Oh, okay. Okay. I guess the echo is gone. Great. So I was saying you, this is very good. This is a very relevant feedback for us, and I think that, as you say, there are at least these 3 areas of where we can work together. With respect to the southbound, maybe it is something that also on our side we need to clarify much better with respect to the past. The point is, I don't know if you think that this point of having an interaction with the controller rather than with the direct devices, first of all, makes sense for you, and second, even if it makes sense, if it is something interesting. This is, maybe you may reply me, give me some hints or feedbacks.
So when you say interaction with the controller, right? I mean, if you look at the way a lot of the providers are implemented in ONOS, you have like an effectively open flow controller, a netconf controller, a PCP controller that are subsystems. But then you could also have an external, like EMS or some other proprietary controller that's provided by a specific vendor. So whether that controller is part of ONOS or external to ONOS, as long as it's able to produce some abstractions of the devices, of the ports, and give us some ability for control that can be tied into ONOS's core, it doesn't really matter.
I see. Now, my point is on the fact that I see that in your specific case you have direct interaction with the ROADMs, and I wasn't sure this is really the case that will match vendors' use cases, but I understood your point, so it's clear to me now.
Yeah, so I guess just to kind of maybe rephrase what I said. I mean, in terms of potentially performance and having additional complexity in sort of the way the network is operated or deployed, obviously the removal of as many intermediate points as possible is sort of desirable in some sense. But if you had an optical network that's controlled through the vendor's proprietary controller, likely we can build interfaces or work around that limitation. So I guess it's not strictly required that the ROTAMs are directly under ONOS's control, especially if you wanted to leverage things like other features that there are no plans to build into ONOS, like you said, the tuning of amplifiers or filters or the specific configuration or maintenance of certain types of links or detection of anomalies or impedances.
Okay. Just I also have my latest question, another question. What do you think the framework for this collaboration, and how can we, let me say, try to see this to foresee this collaboration in order to replicate this also to the other partners? How could this work?
Well, so I don't really have anything that just jumps into mind. I think there's a couple of different models that could potentially work. I think what we should try to do is at least identify rough timelines and synergies in that area, specifically in the area of modeling and sort of enhancements to our southbound around drivers. This is something that you could really easily exploit to and potentially get additional momentum for your project, and at the same time make sure that you're moving in a direction that's congruent with the long-term direction of ONOS. So specifically with those two items. So we should probably at least have some additional discussions about how to go about extending the model and how to go about modeling the southbound configurations, defining some abstractions. That would be where I would start. The intents there we have two. Even though we have some work scheduled there, we have the existing framework and we have plans for revising it. However, I'm not sure, depending on the timelines, what would be the best course of action, whether you should just continue to work with the existing framework and add, enhance it in terms of adding your own intents and compilation mechanisms, or whether it would be better for you to wait or potentially even contribute to the work that we have planned for enhancing the intent subsystem. I don't know there. But in terms of the models and modeling configuration behaviors, I think there's immediate opportunity for syncing up and for embarking in the right direction.
Okay. I'll just, on a more practical side, how this should work, like ACINO could be part of the ONOS community as a sub-project, and we will have to submit the code to you as well for reviews. I'm sorry, this is basically my first interaction with you, so just.
Sure. I mean, there's again a couple of possibilities. I mean, I would imagine that it would be great to have you contribute to ONOS. Whether everything goes to ONOS or not, I'm not sure whether that makes sense or whether you want that. But I definitely see a couple of areas where you could contribute directly to ONOS and essentially move the platform in a direction that would be that would help ACINO project, and that would essentially subsume some of the ACINO functionality. Whether or not you want all of it in there, it's again depends on the degree of autonomy you want and control over your project. So I think that probably is some sort of a mixture between having some portions of your project be entirely separate and some being subsumed or delivered as part of the ONOS code base. It might be a viable option.
Okay.
And we also have online here with us in a room David Boswell, who's our ONOS community director, and I'm sure he will be able to provide some feedback. Okay. So I don't at first glance I'm not sure I have enough.
Of course.
Give it enough thought to know exactly which model we should use. That really will also largely depend on what you would like to see from this, right?
Yes, of course. Just to mention that we are totally interested in having also some visibility and give some contribution back to the community from which we are taking part of the material that we develop, basically. Because, of course, starting from ONOS and with the packet optical use case you developed, it is very, it is something that gives us the possibility not to start from the scratch. So this is very useful, and we really appreciate that. So we think it is important to give something back to the community. At the same time, it is also important for us that the community and being within ONOS, and if we will be able to be something that's ONOS code based, is also some. It is a good form of exploitation of the project results, and for the on a European side, it is a nice way of showing we achieved good results. So I guess it is a bi-directional benefit.
And this is David, and to build on what Thomas said, I think it's great that you're interested in contributing, and if I can help answer any questions you have, just let me know.
Okay, I guess I just sent you a few, like I guess 1 hour ago, something like that.
So what I would suggest as next step that we perhaps set up another maybe meeting where we can, now that we at least know some of the basics and overview about ACINO, that we can maybe break into focus on individual areas and figure out what we want, how well do the timelines align and objectives align, and then maybe we can piece by piece and decide how to best collaborate in these areas. Does that sound good?
Yeah, that sounds definitely good. We will have also a project meeting next week, so I will report this to the consortium, and we'll try to progress on some of these areas so that we will have the chance to be more precise and more concrete in the next meeting with you.
Sounds great. Well, thank you again for your time, and sorry for the delayed start, but it looks like it was a successful meeting after all. So,
yeah.
Thank you. You guys have a nice evening.
Thanks.
Thank you. Bye-bye.
Bye-bye.